Good day, everyone. My name is Pallepaul Mejame, a doctoral researcher at James Cook University. I'm here to present my work on CEREE, which stands for Rare Earth Element and Circular Economy. So CE for Circular Economy and RE for Rare Earth Element. So this project has as main goal to introduce circular economy as a sustainable development model that can be used to fight against material criticality. So the project has as main function or as a business model to provide consultancy and a sustainability framework that can be used to fight against material criticality. The main minerals or critical minerals that the project will be focusing on is rare earth element. So what are rare earth element, where they are or where are they found, what are they being used for, and how significant are they? So rare earth element are 70 critical minerals. Usually we just call them RE as abbreviated here. So they're found in one geological database, and they're practically made up of every devices or application we use nowadays. So for example, we have smartphones, computer screens, wind turbines, electric vehicles, solar panels, etc. So they are mostly used, especially in the clean energy sectors. They are very essential in this particular element. So here I have some of the applications where these metals are being used. So we can see like in energy efficiency sector, we equally have our wind turbines, we have disks, we have that's computer disks, we have the whole lighting system, and equally in these applications also. So what are some of the problems we are trying to solve here? So though these metals are highly demanded in these areas, mostly to reduce global environmental concerns, these metals are faced with a very high supply risk disruption because of the high demand in these applications, and equally with the very low supply or availability in just few nations. China dominates most of the supply, almost 70% of the supply currently. And then also, to make it worse, most of these metals have a very low recycling rate in Australia and in many other parts of the world. So for Australia, for example, the recycling rate is less than 1% in Australia and most other countries. Most people don't focus on the recycling because of the cost and no financial benefit they see in these sectors. So here we have a way of validating a problem where we talk about how RE is this problem and what is the benefit, which include mitigation strategies, and does it worth it? We explain more reason why it is worth, because it's the metals are important in low carbon economy. They are good to reduce economic, they can go to reduce economic or political conflict, because since, for example, China dominates the world supply for this metal, in case of economic conflict between, let's say, China and some of these countries that depend on China, there could be supply disruption. They can place embargo. China has done it. They have done this so many times to Japan and even to the US recently. So this brings us to the necessity of our project, which is to introduce a circular economy framework for rare earth element that can be used as a way forward to fight against this material criticality. So here we have a framework that can be used to improve our resource efficiency for these metals by closing any gap in the production or consumption sector. So it should be a circular system. Here we have a more demonstration about it. And by so doing, we believe this can reduce supply risk and associated environmental impact, especially if circular economy strategies are being applied all throughout the whole system as a detailed here. So our main focus is on consultancy, which we think about providing a sustainability framework and strategies to target partners such as we have industries, we have recyclers, we have policy makers and the government. The government is very essential because these critical minerals has attracted Australia government attention recently, especially because the government is investing so much in the critical mineral sector. Because some of these sectors include, we have, like I mentioned before, clean energy sectors. We have our wind turbine, we have our solar panels, where the government recently has been pouring millions of dollars into the sector to improve on our critical mineral efficiency. For example, we have this Trailblazer initiative program, which JSU is part of it, where the government has invested roughly $250 billion to improve on our research on our critical minerals and clean energy sectors. This should be a research between universities and industries as partners to improve on these sectors. So these are some of the reasons that make our project very efficient, because we come in to provide some of these services. For example, you have currently Australia, we have e-waste where they said it contains a significant amount of these metals. Australia, however, export majority of the e-waste abroad, which in terms of circular economy, this is a very big loss, because according to Work from Waste, Australia waste contain approximately 6 billion tons of metals, which is most of them are lost to this export abroad and landfills. So according to the report, Australia lost about 2 billion worth from waste annually because of these activities. So this make our project very significant as we come in to provide sustainability strategies and frameworks that can be used by these various partners or communities to improve on resource efficiency for the consumption of these metals. Strategies that are not only essential for rare earth element, but for other critical mineral sectors, as is a general or a common problem in Australia and most other parts of the world. So this brings us to the end of this presentation, and we hope to call more people to come in and assist us with this project. Currently, we have expression of interest from the circular economy chairperson from Townsville, which is a good start, and we hope to have more partners to work on this project. Thank you.